I'm getting the hang of this. Finally, our last vocab is secant. A secant. And remember, again, a secant is usually a line, but I suppose it could be a ray. It's or a segment, I guess. Secant line. It could be a segment as long as it goes through the circle, or ray. Usually we talk about a line. A secant line is a line that intersects the circle at 2 points. So the key difference is a secant slices through the circle. So you notice this guy right here, this is a secant, this AB is a secant line, right? Secant line AB with the arrows. So it slices through the circle, it doesn't stop. So if you remember the other ones, a chord stops, its endpoints are right here, this is a chord. And we also had the tangent line, which would go through and just touch the circle once. Right? This is a tangent line. But a secant line goes all the way through, slicing through. Okay, so we're on Theorem 12-11. So we have talked about, so far, two types of angles. You don't have to write this down. We talked about central angles. Central angles where, let's say this is 60, then this would also be 60. Central angles are congruent. We've talked about inscribed angles, so again, you don't have to write this down, but inscribed, so if this was 60, this would be half, this would be 30. And then a third and a fourth type today will be angles that are formed inside and outside of the circle. So first off, if we have an angle that intersects inside the circle, it is going to be half of the sum. It's going to be half of the sum of the intercepted arc. So notice this angle 1 here, this is an example of that. Notice that he's not in the center. This is not a central angle. Right? This is not central angle. Because if it was a central angle, it would be just this guy right here. But instead, the measure of angle 1 equals half of the sum. So x plus y. Okay, the measure of this angle on the inside is half of the sum. Okay, that's the key thing right there. On the other hand, if we have something that intersects outside a circle, it is going to be half of the difference. Half of the difference of the intercepted arcs. And this could be many different cases. You could have two secant lines. Remember, secant lines are the kind that slices through. So here and here, angle 1 is going to be half of the difference. So x, the angle is half of the difference of x minus y. You could also have one tangent. So here's the tangent line, one secant line. So again, angle 1 equals half of the difference. Or you could just have two tangent lines. So x minus y. In any of these three cases, the angle is half of the difference. So let's practice a couple of these. The only thing you have to remember is, ask yourself, is it going to be half of the sum? In other words, is it inside? Or is it going to be half of the difference? Is it outside? So let's look at this one here. I'm going to solve for this w here. He is an arc. Where's that arc? See, that arc goes from here all the way. So that's a pretty big arc. And that's 110. And this is 70. Okay, so let's use this angle here. So the angle in this case, which is 70, so the angle equals half, and then you have to ask yourself, is it the sum or the difference? Well, you look at the angle. The angle's here. The angle is it inside or is it outside? It's outside, so it's going to be half of the difference. So the angle the angle, which is 70, it's not our variable here, the angle is 70, equals half of the difference. So we're going to subtract the bigger one minus the smaller one. The bigger one's W, and the smaller one is 110. Okay, so we have solved for W. You have two options here. You could distribute like that, but rather than doing that, I'm just going to clear out this 1/2 by multiplying by 2. You could distribute, but it just saves a little bit of time here. So I'm going to multiply by 2. 2 over 2 is an equivalent form of 1. So we get 2 times 70 is 140 equals W minus 110. And to get W by itself, we add 110 to both sides. And W equals 250. It's not 25, 250. Now, we did this using this example, but some of you guys probably caught on that, whoops, there was a much easier way we could have done this problem after I zoom out. You see how if you take the red and the green combined, you see how it just makes a full circle? You didn't really have to do this 70 part. You could have just said, all right, I know that W plus 110 equals 360. Subtract 110 from 360, you get 250. So you didn't have to do it. I just kind of wanted to show you this way. If there's an easier way, like this case, feel free to use the easier way. But in this problem, you have to kind of work with what we've been doing. So we've got an angle. We ask ourselves, is this angle here inside? Is it the sum, or is it the outside, the difference? Again, the angle's outside. So the angle equals half of the difference, not the sum. So the angle, this time we don't know the angle. Last time it was 70, this time it's y. Y equals half of the difference. So 110, the bigger one, minus the smaller one, 30. So we're going to get 1/2, 110 minus 30, so that's going to give me 80. And so y equals half of 80, so y equals 40. All right, let me just keep that up here for a second. So here again, we ask ourselves, all right, this angle here, I got the z here, but this angle, is it inside, is it the sum, or the outside? Is it the difference? Again, this is outside for the third straight time, it's the difference. So let me come over here. The angle is half of the difference. Okay, so it's going to be the angle, it's not the variable this time, we know it's 20 degrees, equals half of the difference. So we subtract, again, the bigger one minus the smaller one. Bigger one, 95, minus the smaller one, z. Okay, so again, we can distribute here, but then you'd have some kind of fraction here. But so rather than doing that, let's just clear out the 1/2 by multiplying by 2 on both sides. So 40 equals 95 minus z. Okay, a couple options. You can move the z over, or you can subtract 95 on both sides, either way. Let's do it this way. So 95 minus 95 is 0. So we have negative z equals 40 minus 95. So just pretend it's 95 minus 40. So 50, 60, 70, 80, 90, 95. So that's going to be negative 55, right? The negative team is stronger here. And then we just divide both sides by -1. So z equals 55. All right, last one. So here, finally, we look and see this angle right here. We ask ourselves every time, is it formed inside? Is it the sum, half the sum? Or is it outside? Is it half of the difference? And finally, these first three were all outside, half the difference, outside, half the difference, outside, half the difference. This is finally formed inside, but it's not a central angle. So we can say yes, this angle here is half of the sum of these two intercepted arcs, right? This one and this one. So the angle is x. It is half of the sum, so 46 plus 90. So half, you could clear out by multiplying by 2, but since we have x over here, let's just add this up. Well, it's 136. Okay, and 136 over 2. So x equals 136. Half of that. I could either do long division. I could say 136 divided by 2. But I'm going to break this 136 down into two things that are much easier. I know what 120 over 2 is. And let's see, 120 plus what gives me 136? 120, 130, so 16 over 2, right? I can rewrite 136 over 2 as 120 and 16 over 2. This is 60, and this is 8, so I know that 136 over 2 must be 68. And of course, you could have done long division as well. It's probably a little bit faster, but I think this way is cooler because you can do it in your head eventually. Okay, so we're nearing the end here. It's our last couple of theorems, theorem 12, 12. Now this one, a lot of people have trouble remembering it, so I'm going to try and give you a little bit of a trick to remember, but the way that it's described is not quite a good way to, well, let's just look at it. For a given point on the given point and circle, the product of the length of the two segments from the point to the circle is constant along any line through the point and the circle. Which probably makes no sense. So let's just take it one part at a time here. The first part, there's three different ways you can interpret this. If you have two lines that cross inside the circle, these guys make proportional, similar triangles. So we can say, therefore, that, here and here, A over D equals C over B, which means A times B equals C times D if we cross multiply. Okay, so let me just show you one of those. Down here. So look, we've got, that doesn't work, that doesn't work, this one. Look, they're crossing on the inside. So we can say that this times this, 6.5 times n equals this times this, 3 times 7. So we're going to get 6.5m equals, 21. Divide both sides by 6.5. Now that's a little bit ugly, so let's clear out this decimal by multiplying numerator and denominator by 10. It's going to be 21 times 10 is 210 over 65. Okay, we can do something with both these guys. So 210, that's like 3 times 70, right? 3 times 7, 21. 70 is 2 times 35, and that's 7 times 5, so 65. Well, that's 5 times, let's see, 5 times 10 is 50, and I need 3 more 5s, right? So 13. 13 cannot be broken down, so we're just going to get 13 times 5. Well, at least we could go with this one. We could divide them both by 5. So we're going to get, see, what's this? 21 times 2. 21 times 2 is 42 over 13. Or you can convert it to a decimal. That's fine, too. Okay, the second couple, back up. No, sorry, let me do this proof here. So I didn't prove all the second two, but let's just prove, why does that work? So again, we're trying to say, why does, if they're crossing inside the circle, this times this equal this times this, why does that work? So I try to tell you that they work similar triangles. So let's prove that. So if we draw AC dB here. If you notice, look at this angle C here. This angle C, look at that inscribed angle, or intercepted arc. Right? C intercepts this arc here. And look at angle B here. Oh, he intercepts the exact same arc. We learned a theorem about that. If they intercept the same arc, they're going to be both half of this guy, whatever it is. If this is 100, I'm not saying it is. If this is like 120, then these will both be 60, 60. Whatever they are, it's not 120. Then they're going to be congruent to each other, right? These are congruent. Okay, what else do we have? Oh, we have vertical angles, arc, arc. So, we have that this triangle right here, and this triangle right here, APC, triangle APC, and triangle DPB, are not congruent, but by angle, right? Angle, they are similar. They are similar. So because the triangles are similar, the sides are proportional. So we can say, who is the long side here? A to D, right? Long side to long side, right? Long side to long side, equals short side, C to B, right? Long to long equals short to short. If we cross multiply, we get A times B. In other words, this times this equals C times D. This times this. So that's why that previous one worked. Okay, I don't have proofs for the other two. Let me just explain them. So what do we have here? So we have, if we're on the outside here, we've got two kind of secant lines. We have W plus X, so this whole line here, W plus X times just this outside part W equals Y plus Z times just Y. Okay, now let me come over here. We have Y plus Z times, again, just Y equals T squared, which would be T times T again, so T squared. So this is kind of confusing. The way I like to remember it, even though this is not really mathematical in any way, I just remember the outside part times the whole part equals the outside part of the other one times the whole part. So the outside part times the whole part equals the outside part times the whole part. So if you look at it, that's what's going on here. I mean, really, you've got the outside part, W, times the whole part, W plus X, equals the outside part, Y, I kind of flipped it, times the whole part, Y plus Z. Same thing here. You've got the outside part, Y, times the whole part, equals the outside part, T, times the whole part, which is T again, so you get T squared. So outside times the whole equals the outside times the whole. Out times the whole equals the outside times the whole. Sorry, I don't have like a super proof for that. We're just trying to get through this right now, so let's try a couple practice problems. So these are definitely not crossing in the middle of the circle like the other one did, so we're going to use our little trick here. We have the outside part times the whole equals the outside times the whole. Okay, so what is the outside part? Over, there we go. Outside part, let's just pick a line. So the outside part would be 6 times the whole part. 6 plus 8 equals, let's take this line, the outside part, 7 times the whole, 7 plus y. So we're going to solve for y here. Let's just go ahead and simplify all this. So 6 plus 8 is 14 equals equals 7 times 7 plus y. You can either distribute or divide by 7. Let's just figure this out first. So 6 times 14, well 6 times 10, just that 10. 6 times 10 is 60. 6 times 4 is 24. 60 plus 24, 84, equals 7 times 7 plus y. So again, you can distribute the 7s, or you can try to divide this by 7. I think that'll work nicely. 84 divided by 7. If you think about it, 7 goes into 70 10 times, and then you're at 70, and then you just need 2 more 7s to get to 84, right? 70, 77, 84. So if you do long division too, that's going to give you 7 goes into 14. So 12 equals 7 plus y, subtract 7, y equals 5. All right, let's just do one more here. So this time we got a little tangent line, but that's okay. Just remember my little trick here, the outside times the whole equals, sorry, I have to erase this here. The outside times the whole. Okay, so what is the outside? Let's take this one first. The outside is 8 times the whole, which is 8 plus 16. Or you can just do that in your head if you want. And the other line, what is the outside part? It is z times the whole, which is z again. And we get z squared. That's where the z squared comes from in the formula. So z squared equals 8 times, what's 8 plus 16? That's going to be 26 minus 2, 24. All right, so let's do this in our head. 8 times, that's not a 2, that's a 20. 8 times 20. 8 times 20 is 160. And let's do this 4 here. 8 times 4 is 32. 160 plus 32. It's going to be 192. So z squared equals 192. Square root both sides. Z equals the square root of 192. But let's see, actually I shouldn't circle that. Let's go ahead and simplify that. We're out of space over here, so let's go ahead and work over here. So z equals the square root of 192. Can we work with that at all? Well, let me just see if I can break this down. 192, I know I can divide that by 2. Let's just use long division here. 2 goes into 19 9 times 18, 96. Divide that again by 2. You don't have to use long division, of course, you can do it in your head. 8. So 48. And let's see, okay, so that's going to be 2 times 24, 2 times 12, we got a lot of 2's in here, 2 times 6, 2 times 3. So I've got 2 times 2 times 2 times 2 times 2 times 2 times 3. Wow. So really, I can imagine all these under my square root. Okay, I can put it in. I'll put it. 1, 2, 3, 4, 5, 6. 64 times 3, in other words. So I can take out this 2, and this 2. So I get 2, 2, and 2. 2 times 2 times 2 comes on the outside. That's going to be 2 times 2 times 2 is 8. Square root of 3. 8 root 3. And you can check, if you put that back in, 8 squared is 64. 64 times 3 is 192. Okay, so continuing on here, we're talking about angle measures and segment lengths. Again, recall an angle formed on the inside of the circle. The inside of the circle is going to be, zoom out a little bit, half the sum, right? On the inside is going to be half, keyword half the sum of its intercepted arcs. An angle formed on the outside is going to be half of the difference. Okay? Half of the difference. The other two things, for any two chords intersected in the circle, the products of the two pieces are equal, so we multiply them together. We'll practice that. And for two secants, or one secant and one tangent, it's the outside times the whole equals the outside times the whole. Okay, so the outside times the whole equals the outside times the whole. We'll practice that. So let's again try some of these guys. So let's take a look here. Number 2, we want to find this x here. Okay, so ask yourself, is this angle on the inside? Is it the sum? Or is it on the outside? Okay, so clearly this angle is on the inside. Now, remember, inside, you don't have to draw this, but inside could be something like a central angle. If it was a central angle, remember if this was like 50, then this would also be 50. It would just be the same. But this is not a central angle. The center is like right here. This is not a central angle. Remember, we also talked about inscribed angles. So that would be something like this, where the edge is right on the edge here. So if this was, I don't know, 50 again, remember this is half. So we had two types. We had the central angle, that's not it. We had inscribed, it's not it. Notice how it's just kind of floating in the middle here. So it's neither one. So rather, since it's on the inside, we say that the angle is half the sum of the intercepted arcs. The angle is half the sum of the intercepted arcs. Where are my intercepted arcs? They are here, kind of like forward and backwards. Here and here. Here and here. So the angle, which is x, the angle is half the sum. So let's add up. Sum means plus, right? 193 plus 61. Okay, 193 plus 61, we'll add that up by hand out here. 3 plus 1 is 4. 9 plus 6 is 15. So we get 254. Okay, so x is going to equal half of that. Well, what's half of 200? It's 100. What's half of 50? It's 25. What's half of 4? It's 2. So half of 100 plus 25 plus 2. Right? Half of 200, half of 50, and half of 4. So we get x equals 127. Excuse me. Okay, let's take a look at number 4. So again, where is our angle? Let's see. Here's our x. So he looks like he's an arc. Where's the actual angle, though? It's right here. Right? What is this angle here? Is it on the inside? Is it a sum? Or is it on the outside, where it's a difference? Again, this is on the inside. It's not a central angle. It's not inscribed. It's just inside. So we can set it up again where the angle equals half. Since it's inside, it's going to be the sum. The angle equals half of the sum. Well, so what is the angle? The angle is not x. The angle is 96 equals half of the sum. What am I summing up? I'm summing up 140 and x. So half of the sum, 140 plus x. Well, how do we get rid of this 1/2? Again, half is the same. You just multiply by 2. That is the inverse operation there. So multiplying by 2, 2 over 2 makes an equivalent form of 1. 2 times 96. 2 times 90 is 180. 2 times 6 is 12. 180 plus 12 is 192 equals, and this whole thing went away, so we get 140 plus x. Subtract out 140. you get x equals 2, 9 minus 4 is 5. X equals 52. Okay. Here, so number 10. So now this angle right here, what is this angle? Remember, it is not central, it's not the center, it's not inscribed, it's floating. You have to ask yourself, is it floating on the inside, where it's the sum, or is it floating on the outside, where we use half the difference? And here, clearly we can see, here's our circle, it's outside. It's outside, so we know we're going to be half of the difference. We'll call this x. So, back up just a little bit. We know that the angle is half the difference. And again, why do we put difference instead of sum? It's because the angle is outside. If the angle is inside, it's half the sum of the two arcs. So here are my two arcs, 60, 130. We want to subtract, so the angle is x equals half of the difference. We'll subtract 130 minus 60, bigger one first, so we have a positive number. So half of 130 minus 60, let's see. 130, what's the difference? How much space is between 130 and 60 on the number line? Let me just try and do this in my head. So 60 and 100, there's 40, right? This is 40. And then 100 and 130, that's 30 more. So the total difference is 40 plus 30. It's going to give me 70. And half of 70 is 60. Half of 60 is 30. Half of 10 is 5, so I get 35. X is 35. Okay, taking a look here. Again, this is not a central angle. This is not an inscribed angle. We have to ask ourselves, is this angle inside, where it's the half of the sum, or is it on the outside, where it's half of the difference? And again, we see this is on the outside. It's on the outside, so we can use half the difference. So the angle is half of the difference, not the sum. Alright, so here it is. Here's my x. Here's the other part, 60. And my angle this time is 30. This is not x. It was x last time. This time we know our angle is 30. It's the difference. Now, which one comes first? Is it 60 minus x or x minus 60? Remember, you want the bigger one first because you don't want it to be negative, so it's going to be x minus 60. X minus 60. Clear out the 1/2. You could distribute here, but then you're still going to have to multiply by 2 eventually, so I'm just going to multiply by 2 now. Multiply both sides by 2. Again, you could distribute the half. 2 times 30 is 60. We get x minus 60, right? Because this whole thing went away. 2 over 2 is a 1. Add 60 to both sides. And we get x equals 120. 120. And you could try that. I mean, look at this. Take 120, subtract 60. 120 minus 60 is 60. And what's half of 60? 30. So the angle is half of the difference. And it makes sense when you look at these numbers. The angle is half of the difference. All right. One more type of problem here. Now this one is really interesting. Let's call this x here. We could see that, again, my angle, is it on the inside? He's not inscribed. He's not central. Or is it the outside? In other words, is it half the sum if it's inside, or is it half the difference? And again, we see it's on the outside. So the angle is half the difference. So the angle is x is half the, well, here's the thing. Here's my two arcs. Here's 1, here's 1. And the other one, I'm going to do it in red this time so you can see it. Normally they have a label, but I don't know what this is. Well, the clue is, again, red plus blue makes 360. So if this is 240, 240 plus what gives you 360? This has to be 100 and, let's see, 40 plus 20 makes 360, right? 240 and 120. That has to be the case. So now we can finally plug in our difference here. So it's going to be the difference, 240, the bigger one comes first, 240 minus, because it's the difference, and then 120. Right? So you have to figure out what that 120 is, so you can do the difference between these. So x equals half of 240 minus 120 is 120, and half of 120, x equals 60. Okay, so now we want to solve for x. Assume the lines which appear tangent are tangent. So we've got two chords, right? Two chords. We've got this chord and this chord intersecting. As we talked about, if you don't have to do this, but we proved by the AA postulate that these guys form similar triangles. So you could actually make a proportion long to long, 9 over x equals 6 over 4. But you don't have to do this. You don't have to do this. You can simply say that 6 times x, this times this, equals this times this. 9 times 4. And why can we do that? Because really, you're just cross-multiplying, right? 9 times 4 equals 6 times x, right? This times this equals this times this for two chords intersecting inside a circle. So 6x equals 36. Divide both sides by 6, and you get x equals 6. So on this page, why don't we keep going with that problem, like that problem I was just talking about. So let's skip to number 20 here. Skip to number 20. So again, we have two chords intersecting. You could make similar triangles, again by the AA postulate, or you can just say that this piece, 16 times 15, equals this piece, x, times this piece, 10. Okay, so you get your answer. Let's see, 16 times 15. What is 16 times 15? Well, 15 times 15 is 225. So 16 times 15 would just be one more 15. So 225 plus 15, 235, 240. You could double check that if you want. 80, 0, 6, 1, 240. Okay, and then that's going to be 10x. Okay, so you divide both sides by 10, and x equals 24. So whenever you see two chords, you can say this piece times this piece equals this piece times this piece. Why? Again, it's because you can make similar triangles by the angle-angle postulate. Long times long equals short times short. Cross multiply, and you get that. Okay, let's try some of these other ones. Starting at number 18. Remember, anytime it comes on the outside, we can't do this trick here. We have to say something like the outside part times the whole part equals the outside times the whole. Oops, not while, whole. So the outside part, so that would be like this. That would be 8 times the whole. That would be 8 plus 19 equals, let's do this in red, the outside part is 9 times the whole, which is 9 plus x. right. So let's just add these guys up. 8 plus 19. 8 plus 19 is, let's see, 8 plus 20 is 28, so let's be one less, so 27. Equals. Now again, you can try and divide both sides by 9 here, but let's just distribute. We haven't done that. You can distribute here. 9 times 9 is 81. 9 times x is 9x. Let's see, 8 times 27. 8 times 20 is 160. 8 times 7 is 56. So 160 plus 56 is 216, but you can double check that. 2 times 7 is 56. 2 times 8 is 16 plus 5. Yep, 216. Okay, let's get rid of this 81. So 6 minus 1 is 5. 1 10 minus 8 tens. Borrow one of the hundreds here. So 11 tens minus 8 tens is 3 tens. And you still have 1 left. So 135 is 9x. So x equals 135 divided by 9. Let's see what that is. 135 divided by 9. 9 goes into 13 once. And that's 4. 9 goes into 45. 9 times 5 is 45. So that's going to be x equals 15. X equals 15. All right. Let's try one more here. So again, number 22, you've got the outside part times the whole equals the outside part times the whole. Outside times the whole equals outside times the whole. So the outside is 27. The whole would be 27 plus x equals, what's on the other side? The outside part is 45. And the whole is 45. Okay, so let's solve for this. So 27 times 27, 27 squared. What is 27 times 27? Let's break it down doing it this way here. 27 times 27. 27 this way, 27 this way. 20 times 20 is 400. 20 times 7 is 140. Come on now. 20 times 7 is 140, and 7 times 7 is 49. So what would all these be? Let's see, 400 plus, let's see, 140 plus 140 is 280. 280 plus 400 is 680. 680 plus 49 is going to be 729. And then distribute here. So 729 plus 27x. I'm not going to give you such a huge number here. 45 times 45. Ooh. So again, let's break it down. If I give you these huge ones, you can. I'm not going to give you these huge ones in all likelihood. 45 times 45. Again, you can just do normal multiplication if you want. I'm just doing something different for fun. 1600. 40 times 5 is 200. 40 times 5 is 200. 5 times 5 is 25. So let's see. 1600 is going to be 400. Plus 1600 is 2025. So let's subtract 729 from both sides. So we get 27x equals 5 minus 9. Let's borrow that. 15 minus 9 is 6. 110 minus 2 tens can't do it, so let's turn this into 19. So 11 minus 2 is 9. 9 minus 7 is 2. So 1296 equals 27x. Divide both sides by 27. And x is going to equal, let's do the long division here. 27 goes into 12. Nope, 27 goes into 129. Let's make some guesses here. 27 times, well, let's see, 5. 27 times 5, 35. 35. That's a little too high. So 27 times 4 has got to be it. 27 times 4. 8, 9, 10, 108. Okay, so 27 times 4. Subtract. It's going to be 1, 2. Bring down this 6 here, 216. 27 goes into 216. Oh, let's just guess, I don't know, 6 times. So 42, 12, 16. Now let's try 27 times 7, 49, 14, 189. Okay, let's see, 27 times 8. 56, 16, 22 and 16. Oh, there it is, 27 times 8. So we get x equals 48.